In the previous sections, we've been doing a lot of trigonometry by hand. In this section, section 2.3, we're going to use the calculator. So we're going to finally learn how to punch some of this in the calculator. We've done a little already, but the problems here are a little more complicated. So the first four examples say, use the calculator to find each of the following values rounded to 4 decimal places. Okay, so when we've used the calculator before, we've only used it with sine, cosine, and tangent, but now that we have the reciprocal identities and some of these other things, we can use the calculator for the other 3 trig functions too. So the first problem says, find sine of 22 degrees, 16 minutes, 38 seconds. Well, we've done one similar to this before. I mean, we used the sine button before. Now, if you want, you can type this whole thing in as it's written with the degree sign, the minute sign, and the second sign, as I showed you in a previous video. It takes so much effort to hunt for those things. So remember the way I told you I was going to handle angles like this when we were talking about converting from degrees, minutes, seconds to just decimal degrees. I'm going to type that in as 22 plus 16 over 60 plus 38 over 3600. That is so much easier to type in than looking for degrees, minutes, and seconds. So I'm just going to type in sine of that now. Remember, you should still be in degree mode, which means you don't have to put the degree sign. So that's the way I'm going to type that in. I am still in degree mode. So sine of 22 plus 16 over 60 plus 38 over 3600. That is so easy to type in. And to 4 places, I'm getting 0.3791 if you round to the 4th place. Now you should also, when you do problems on the calculator, you should ask yourself, does this answer make sense? Remember, when you take sine of an angle, remember the range of the sine function is between -1 and 1 inclusive. And notice this number is between -1 and 1. So at least it makes sense. I still could have hit a wrong button and got the wrong answer, but at least the answer makes sense. There's no red flag there. Okay, so that's that one. Now the next one says secant of 24 degrees. Well, again, if you look at your calculator, you probably don't have a secant button. I do not. I have sine, cosine, and tangent. Well, we don't need a secant button, because can't we rewrite secant in terms of one of the 3 trig functions, that I have buttons for? Sure. Secant of an angle, secant's a reciprocal of cosine. So this is 1 over cosine of 24 degrees. Now don't take 1 over 24, right? No, the angle stays the same, 24 degrees and 24 degrees. So this is what you have to type in, 1 over cosine of 24. 1 divided by cosine of 24, and I get 1.09 to 4 places, 0946. You round to 4 places. Now, does this answer make sense? Remember, when you take secant of an angle, the answer is 1 or bigger, minus 1 or smaller. This is bigger than 1, so the answer at least makes sense. Okay? Now, problem C, it's a combination of the previous 2, because we're using cotangent, which is not one of the sine, cosine, or tangent buttons, and we have degrees and minutes in the problem. See if you pause the video and see if you could do this one on your own. It's a combination of the 2 previous ones. Okay, so to do this one, I need to write it in terms of sine, cosine, or tangent. Well, cotangent's a reciprocal of tangent. So this is 1 over tangent of 21 degrees, 57 minutes. And so that's what I'm going to type in. 1 over tan, but I'm going to rewrite this as, dividing by the 60 with the 57. 21 plus 57 over 60. And I'm getting 2.4813. Okay. Now, it's kind of silly to ask if this answer makes sense, because remember, tangent and cotangent can be, the range is any real number, so that wouldn't help me. Now, what about this last one? There's several problems in the book that, you could just type this in as 1 over sine of 28, but this particular problem, and some of them in the homework set, they want you to simplify first before you type in. Right, 1 over cosecant, that's saying what's the reciprocal of cosecant? Well, that's just sine. So this is the sine of 28 degrees. So the book wants you to simplify first, and then it's easier to type in. It's much, I think you've got less of a chance of making a mistake going from here to here than you are typing 1 over sine of 28 degrees. So that's why they want you to simplify first. And sine of 28 degrees is about 0.4695 if you round to 4. Okay, so that's just practice with the calculator. Now, in this section, I assigned a lot of homework. A lot of the problems are very short like these. Right? Let me caution you. Just because you have a calculator in front of you does not mean you know how to use the calculator. I cannot tell you how many times I put problems like this on a quiz or an exam, and students miss all 4 of them because they didn't practice. Okay, you can't just because you have the tool doesn't mean you're going to be able to waltz in and know how to do everything on it. Okay, you have to practice. That's why I gave you a lot of homework in this section. Okay, so that's just practicing with calculator. So the new thing here is using the calculator with the reciprocals. Okay, we didn't do that before. Okay, so degrees, minutes, seconds, and reciprocals. Okay, so now that we know how to do that, the next 4 problems say, let me paraphrase, find a value for theta in the interval 0 to 90 degrees. Remember, bracket means include 0, parentheses means don't include 90. That satisfies each statement. Leave answers in decimal degrees and round to 2 places. Okay, so we're going to round to 2 places. Okay. And notice they want the answers in decimal degrees, so not degrees, minutes, seconds, like 22 point something degrees. All right, so the first problem says sine of theta is 0.4271. 0.4271. Okay. Now, so this is a new idea. Think about what we were doing. We were taking sine of an angle and spitting out a number, right? That's what we've been doing. Sine of an angle is a number, cosine of an angle is a number, tan of an angle is a number, etc. Okay? Now, you may remember in college algebra, you had the idea of an inverse function. The idea of an inverse function is inverse functions undo the original function under composition. For example, if you had f of x was x cubed, right? If you take a number, if you take f of 2, for example, 2 cubed is 8. Well, what if you wanted a function that would undo that operation? So you want another function, which we call f inverse. That doesn't mean 1 over. Right? It just means inverse, undo. We want f inverse of 8 to go back to 2. Right? So see, we have the 2 in the domain of f. F took that to 8. We want a function that we call f inverse that takes 8 back to 2. So it'll undo it. So if you take 2 to 8, you want to be able to undo that. Right? So that was the idea. And what did this function turn out to be? Here, f inverse of x turned out to be the cube root of x, right? Because if you take 2 and cube it, how do you undo that? You take the cube root. Okay? So that's the idea of undoing. So notice what we've been doing in this course so far is we've been taking sine of the angle and spitting out the number using the calculator, right? Sine of the angle is a number. We want to undo that. What if you have the number and you want to go back to the angle? That's the inverse trig function, which we write as sine to the minus 1, just like we wrote f to the minus 1 to indicate a generic inverse function. So sine inverse of a number is going to spit out the angle. Okay? And I write this down all the time for myself so I can keep things straight. Sine of an angle is a number. Sine inverse of the number is the angle. It'll undo it for you. Now be careful. The -1 exponent here is the notation used for inverse functions. That does not mean 1 over sine. It doesn't mean 1 over. If you have a real number and you say 2 to the minus 1, that meant reciprocal, right? That meant 1/2. But in this context, the -1 exponent with the function does not mean 1 over sine. We have a name for 1 over sine. That's called cosecant. This is a completely different idea. It's not the reciprocal, okay? Okay, so sine of an angle is a number. So sine inverse of that number is the angle, right? I'm just using this idea to undo it. Sine of an angle is a number. Sine inverse of the number is the angle. So to get the angle, I just need sine inverse of that. If you look on your calculator, most calculators, if you look above the sine button, is the sine inverse. So you have to do, mine I have to do second sine. So I'm going to do second sine, oops, turn off. Second sine, that gives me sine inverse of 0.4271. And so my theta here is 25.28 degrees when you round to 2 places. Now how do I know this is degrees? The calculator gave me 25.283659114. It didn't put a degree sign. How do I, just because the problem said give you your answer in degrees, how do I know this is degrees? Because my calculator is set in degree mode. So If you're in degree mode and you take sine inverse of a number, it's going to give you the angle in degrees. If you're in another mode, it'll give you the answer in the other unit. So be careful, make sure you check your mode. Leave your calculator in degree mode for now. Okay? Okay, so that's the first one. And then the second one says, suppose tan of theta is 3.8125. Okay? So I'm trying to find angle theta. Tan of an angle is a number, so tan inverse of that number is the angle. Notice how beautifully I'm writing out my steps so everyone can follow. You should do the same. Okay, so type that in, let's see what we get. So tan inverse second tan, that gives me my tan inverse, 3.8125. So theta here is 75.30 if I go to two places. Now on both of these problems, what's a way to check your answer without doing the same thing you did again? Well, remember, sine of theta has to be 0.4271. Take sine of that and see that you get that. Now, we're going to be off a little bit because of the rounding, but if I go back and do sine of 25.28, I get 42704, so it's close. So we're probably good. What about here? Tan of that angle should be 3.8125. Tan of 75.3 degrees is 3.8117. So it's close. I mean, I rounded this answer, so that's why I'm not getting a perfect answer back. So check your answer in a completely different way. So they're close. Now, if I typed tan of this and I got 3.7, that's not that close, relatively speaking. So I'd probably double check my work then. Okay. Okay, the next one says, secant theta is 4.8821. Okay? Now, you could say secant of an angle is a number, so secant inverse of the number is the angle. That's a true statement. I mean, secant of the angle is a number, secant inverse of the number is the angle. But what's the problem here? I don't have a secant inverse button on my calculator. And remember, that does not mean 1 over secant. That's not cosine. It's not the same thing. So that's a true statement, but it doesn't help me. Okay? Remember, just like we only had sine, cosine, tangent, trig function buttons on our calculator, we only have sine inverse, cosine inverse, and tan inverse. So we need to change this problem to a cosine problem and then change it to a cosine inverse problem. Okay? So let me change this to a cosine problem. If secant of theta is 4.8821, what's the cosine of theta? It's the reciprocal of that, 1 over 4.8821. I'm not going to bother punching that in. I'll just leave it as it is, right? So I've just changed it to a cosine problem using the reciprocal property. Now, cosine of an angle is a number, so cosine inverse of that number is the angle. Okay? So why did I have to do this step? So I could write it as cosine inverse because I have a button for that. So change the secant problem to a cosine, then write it in terms of cosine inverse. 1 over, cosine inverse of 1 over 4.8821. And theta is 78.18 degrees. Again, if you want to check your answer, take the secant of this, it'd be 1 over the cosine of that, and you should be close to that. 1 over cosine of 78.18 is 4.8819, so that's pretty close. Okay, and then the last one here says cosecant theta is 0.1254. Okay. Again, you could say theta is cosecant inverse of 0.1254, right? Cosecant of an angle is a number. Cosecant inverse of the number is the angle, but again, you don't have a cosecant inverse button on the calculator. So if we wanted to try to solve this, what should we do first? We need to write it in terms of sine, cosine, or tangent. Well, the obvious thing to do is use the reciprocal like we did here. So the reciprocal of cosecant is sine. So if cosecant of theta is 0.1254, sine would be 1 over that, wouldn't it? And then, okay, sine of an angle is a number. So theta is sine inverse of that number. Right? I'm following the exact same procedure I followed here. Change cosecant to a sine problem, then change the sine to a sine inverse. Well, if you type that in, sine inverse of 1 over 0.1254, I get error domain. And we talked about this a while back. My calculator said there's a domain issue. So it's not a syntax error. I didn't leave off a parentheses. It says I'm asking the calculator to do something it can't do. Now, did I do something wrong here, or is that a valid thing for the calculator to tell me? It's telling me it can't tell me a theta with this property, and that makes sense. Go back to the original problem. We could have realized that in the original problem. Remember when we did ranges of the trig functions? Remember, if you look, have the number line from -1 to 1, sine and cosine gave you values between plus or minus 1. Secant and cosecant were values 1 and bigger or -1 and smaller. And notice this is cosecant's 0.1, which is here. And so sine and cosine can be 0.154, 0.1254, but cosecant can't. So there's no solution here, no solution or undefined or whatever you want to write. Okay. So we could have realized right here, cosecant can't be. Remember we did the problems, is this possible or impossible? Cosecant can't be 0.1254. We could have said no solution in the very first step. But if you didn't notice that, I wanted you to see what the calculator would tell you. Notice here, we were going to get a solution. Can secant be 4.882? Yes, 4.882 is out here. Can tangent be 3.8125? Yes, because tangent could be anything, okay? I cannot tell you how many times I've had students on a problem like this say, no solution. Because they do something funny here, or they do something wrong with the calculator. There's going to be a solution here. Secant can be 4.882. Right? 4.882 is bigger than 1. There's going to be an answer here. Tangent can be anything. There's going to be an answer here. Now here, cosecant cannot be 0.12, so there can't be an answer. And our first problem was sine of theta was 0.4271. 0.4271 is between plus or minus 1. There's going to be an answer here. So ask yourself that question before you do the problem. Is there going to be an answer? Is this possible? Yes, there's going to be an answer. Is this possible? Yes, there's going to be an answer. So if you ask yourself that question, then you get an undefined, you might want to rethink your work here. Okay, now let me go back for a second with some actual syntax issues on some of these problems. Now I did everything with positive angles here. So let me address if some of the angles were negative and you want to use a calculator. If you had a problem that said, for example, sine of -22 degrees 41 minutes, okay? If you type that in exactly the way it's written with the degree sign and the minute sign, the TI-84 will be perfectly fine with it. Now, if you try to do it the way I do it, like dividing by the 60 stuff, if you do this, right, like I did before, that's not going to be the right answer because of the negative. Think about what this is saying, right? -22 degrees, you come down 22 degrees, but then you keep going in that direction another 41 minutes. And notice what I've done here. I've written -22, and then I've gone back 41 minutes. So you have to be careful. If you have a negative angle and you want to type it in the way I do by dividing the minutes by 60 and the seconds by 3600, you have to put a minus sign everywhere, okay? So be careful. Or you could do it this way. Sine of negative of 22 plus 41 over 60. You could do it with that with the double parentheses. Because now when you distribute the negative, you get both. So watch out for that. So again, if you like doing the degrees on the minutes, you can type it in with -22 degrees 41 minutes and you're fine. If you like dividing by the 60 business, put the negative everywhere. So if there had been seconds here, 10 seconds, you would have said -10 over 3600. So that's how you could type that in. Or you can just put parentheses around the entire thing. Right? Keep it plus plus, but then put the minus all the way out front. But there's a lot of parentheses here. So when I have one like this, I type it in with the negative everywhere like that. Now another issue you may see is if you're asked to find something like cosine, I don't think any of the problems have this, but suppose you wanted cosine of 50 minutes, like that. If you try to type this in exactly the way it's written with the 50-minute sign, the calculator's not going to like that. Again, I would type this in as cosine of 50 over 60, done. Okay? But if you like using the degrees and minute signs, what you have to type in here is cosine 0 degrees 50 minutes. You have to write in the 0 degrees ahead of it, or the calculator's not going to like it. But yeah, I would just say cosine of 50 over 60, done. But if you like using degrees and minute symbols, you have to put the 0 degrees ahead of that. Same thing if this had been 50 seconds. I don't know that I've actually tried this, but my assumption is you'd have to do this. 0 degrees, 0 minutes, 50 seconds. I actually haven't tried that, but my guess is you're not going to be able to type this in by itself. It's probably not going to like that, at least on the TI-84. Okay, so that's the calculator section.